Then just before the break, we're able to build our profile, draw the profile itself, and fill some rows in my profile. Number one is the station. Next is existing ground, and you have to do nothing about them because those are totally given to you for the invert elevation or the final elevation. Uh, Typically, you will be given an elevation and a slope where you can find all the elevation and failure table. The last one, which is this one here. So this one here, it's something called the depth of cut. And I need you to understand that simply at this point of time, those numbers are unknown. So I'm going to hide them for now. Then I'll show you how to do that later on. But let's understand first the meaning of depth of cut. The way to understand the meaning of depth of cut, we have to look at our cross section again. So you guys remember, this is my cross section, and this is how situation will look like when we build our or install the sewer. You guys remember that we send our surveyor to simply find for us this something called EG, which is existing ground elevation, and my designer will give you also the invert elevation. Now, the depth of cut is something very simple, which is from this point going down vertically to this point here. This is called depth of cut. Depth of cut, no super signs, which is geometrically. How can we find depth of cut? There is no sine, there is no cosine. The depth of cut is simply the difference between the existing ground and the pipe invert. And so the way we do it is we go to the table, we simply move this guy, and we say, okay, you know what? How do we estimate this number? Here, very simple. We say, what is my existing ground elevation at this point? It is 110, 110.3. And what is my invert elevation at the same point, at the same section? 108.4. And this will give me a 1.9, I guess. And simply the 1.9 is the depth of cut. Let's see. So I'm going to move this one here. And here we go. Here is my depth of cut. What we have to do is need to repeat the process so many times. It depends on how many sections we have. So let's do it one more time. So how can we find the 2.4? Look at this. So we go ahead and say 110.7 minus 108.3, you get 2.4. You repeat this over and over and over until you simply fill all the depth of cut in your table. Now we have a depth of cut. So what's next? So to show you what's next, very important to understand the meaning of depth of cut on the profile. For example, watch this. If I simply click from here to there, can anybody tell me how much is that right away from your table? Don't calculate anything. It is in the table. Can anybody help me? What is this dimension?
2.8.
Exactly, 2.8. And you guys, by the same token, you will see that this dimension also is from here to there. This is your depth of cut, which is 2.4. And then finally, this depth of cut from here to there is 1.9. Now, I'm going to go like a little bit outside the topic, and we will discuss something. It's pure geometry. It is pure mathematics, which is now our goal is to find the side area, at least for now. We want to find the side area. And what side area is? It is simply the thing, the area between the magenta line, which is existing ground, and the invert or the pipe. And you can see in my picture here, I simply hatch. Okay, I hatched the side area. So the side area, it is something, it's complicated because it's not really a square or rectangle or a circle. It is, you can see it goes up and down. And the way we find the side area is by dividing the side area into smaller pieces that we can find, and then we simply sum those areas or integrate as you may think. Okay, so really what it comes down to, let's find this small area here and then find this small area here and keep going. And if we are able to find all those small area, I'm referring to this area here and this area, and this area here. And then if we're able to add all of them all the way to the end, guess what? We're able to find the side area. You guys agree? Please give me a confirmation. Do you agree?
Yes.
Okay, so you know what? I'm gonna show you some steps, but and then we'll give you the rule. So let's do the first one. So forget about the entire side area. Let's focus only for this one for now. You can see, what do we call this figure between the magenta and the blue? Is it a circle, a square, a rectangle, or something else? Any help? Anyone is good at math to tell me what do we call this figure between the magenta and the blue and those two vertical lines?
Trapezoid.
Trapezoidal.
Thank you so much. That's exactly the name I'm looking at or looking for. Okay, so the area of trapezoidal, it's on my slide somewhere on the next slide, but I think some of you already can remember that, huh? If I give you the dimension, this dimension is 1.9 and this 2.4, and don't ever forget that this dimension is how much? Anybody remember how much is this dimension? 25 meters. Okay, so I need some help, please. I need some help. Somebody would tell me what is area 1. Where area 1 is not really the side area, it's just a partial side area. So area 1 equals, any help? Oh, come on. That's a trapezoidal shape area.
53.75.
No, please tell me the details, because the details is what will lead us to the general equation, please.
Average, I don't know, average your two heights. So
1.9
plus
plus
2.4 divided by 2
divided-
times 25.
Okay, perfect. So you can see it's exactly like you said, it's 1.9 plus 2.4 divided by 2. And remember, this is an average, huh? So I'm going to box it out. This is an average. And then once you get the average, then you multiply times 25, which is the height. Now, let's do it quickly on the next one. Okay, so I'm going to copy this one here. So Control C and Control V, and then take it here. And this will give us A2. How can we find A2 quickly? Any help? So 2.4 plus 2.8 divided by 2, and then divided by 25. If you guys agree, please confirm.
Yes.
Okay, so you know what? We're very close to give you the final formula. Now we need to have some observation, okay? Some observation. I'm asking you guys, for sure we can go ahead and find A3 and A4, and then we add them together, and this will give us the total side area. But I will work smart. I will show you a smart way to find the entire area without doing the individual smaller area. But we need some observation. I'm asking you, do you think this term here, which divide by 2 and then multiply by 25, does it repeat if I continue and find A3 and A4?
Yes.
Yes.
Yes. Guys, remember, when something is repeated, can we take it as a common factor?
Yes.
Yes.
Yes, we can. Okay, Nick, that's the first observation, huh? So we're going to take 25 over 2 as a common factor. Number 2, please let me ask you, do you see here 2.4? You see here 2.4, okay? So that's a 2.4 here, and you see 2.4 here. Anybody knows why do we see 2.4 twice?
So it's in the middle of the two slices you're looking at?
Perfect. Thank you so much. I'm asking you, if you go ahead and do A3, would you see 2.8 twice? Yes or no?
Yes.
Okay, but I'm asking you, would you ever see 1.9 twice?
No.
Done. We're done. So this is really what I need to show you, our final equation. Watch this. So after this discussion, you know what? I'm going to clean things up, and I will give you the final equation, which something called trapezoidal rule, which is not really a rule. It is someone who is really good at math and did some observation to come up with this rule. Watch this, please, and you will see this rule here It saves your effort. You don't have to find the individual small area. Rather, right away, you can find your total area, site area. Watch this. I'm going to say here SA, an SA for site area. You guys remember I said that 25 over 2 is a common factor. That's why watch this, 25 over 2. It's a common factor, huh? And then I'm going to have a big term, and then I will have a close it, okay? So this bracket is a big term. And then I'm going to make two terms, plus, and then another term, okay? You can imagine, I'm just showing you the structure of the formula, then it will make sense for you. So a term, 25 divided by 2 multiplied by a term, and then plus another term, okay? Now let me ask you, which one among those depth of cut will show only once?
First and last one.
Thank you. So here we go. So 1.9 plus the last one is 2.85. And look at this. I'm gonna, if I write here 1 times, does it matter? If I write here 1 times, doesn't change anything. So that's why we don't do it. We don't say 1 times because it doesn't change anything. However, which one will repeat twice? Everything, not, but excluding the first and the last. And that's why there is a missing 2 here. Why missing 2 here? Because every one of those terms will repeat twice. And that's why, watch this. I'm going to say here 2.4 and then plus 2.8 plus 1.93 plus 1.85 plus 2.35. Hopefully, you get the idea. So the idea is, equation is very simple. You take the common factor 25 over 2, which is here, this one, and then you have a big term, and then there are smaller terms. The first one, though, this is the first and the last, because they are repeated once, and they will be multiplied by 1. And then plus 2 multiplied by the sum of everything in between the first and the last. Now, can anybody tell me, is there any condition to use this method to find the side area? Because we have an assumption. And the assumption is this 25 is constant. If you agree, huh? Let's agree that this method requires that the base of trapezium is constant all the way to the end. Otherwise, we cannot use a 25 as a common factor. That's a mathematical fact, huh? If 25 is constant, then I can take it as a common factor. If it's not constant, for example, 25 and then 25 and then 25 and then 30 and then 25, it means we cannot involve this part in our calculation. Do you guys agree?
Yes.
Congratulations, you have learned the first method, which is called trapezoidal method. And this method doesn't do anything more than it just finds for you quickly the side area without you pain and then find those individual smaller area. Right away, it will give you the side area. Now, a question for you. In this class, are we trying to estimate the side area or we need to do further step?
Volume.
We need to find the volume. And now here we go. We're hitting the last step. Now, to show you how we go from side area into volume, I'm going to do something like magic. You will see it right now. This guy here right now is simply a 2D. Huh? So what you see here is a 2D. 2D. So I'm going to show you right now, if I turn this using very few lines into 3D, you will see how can we find the volume. Watch this. I'm going to take this guy here and extrude things in 3D. So, okay, so I'm going to extrude this in 3D. And to match my profile, I will have to change color. So this line here will be magenta. So this is your existing ground. And this line here at the bottom, this will be blue if you agree. Okay, and then few more lines. So another line here, which is the existing ground. So this guy is also blue, magenta. And at the bottom here, another line, and this line is another blue. So I change this line here to blue, and then I'm going to, make a line here, and this line here, I will also make it blue, but I will change my line type to dashed because it's supposed to be hidden from this point. I don't want to extrude the pipe because it will make you confused. Now I'm asking you on this picture here, where is the side area? Watch this. So the side area is here. This, sorry, that's my stamp. So this is the side area. Okay, so this is side area. Okay, and so the area between the magenta and the blue side area. Now, finally, what do you think? How can I, from after I find my side area, how can I find the volume? Any help? Shouldn't be very difficult, by the way, based on this 3D picture.
Time with the width.
Yes, thank you so much. So to find the volume, it is as simple as you find the side area in meter square and then multiply by the width of the excavation, which is 1.75. Because the volume is nothing more than taking the area and extruding the area by how much? By 1.75, 1.75 meter. So finally, the volume is going to be side area multiplied by the width of the excavation. So here we go. So now you learn your first method. Now I'm going to extend the discussion a little bit. So what happens here is to find the side area. So far, what we learn is a method called trapezoidal method. And this method here, look at the name, trapezoidal method. So it assumes that it's simply multiple trapeziums next to each other. And remember, when we say trapezoidal, there is an assumption here. What's the assumption? Any help? Look at this. So this is one of the trapezoidal shapes, okay? And to make it, to guys, so you follow me, here we go. So this line here is your blue line. This is your blue line, which is the pipe. How about this line here? How about this line here? This line here is simply the magenta line, which is your ground. And let's make it change the color. So that's one thing. Also, probably I'll change the line type so you guys can see better. So really, the trapezoidal method is splitting your area into smaller trapezoidal shape. So what's the assumption? The assumption here is that your existing ground is a line. The assumption, if you say I'm using trapezoidal method and it gives you the number, trapezoidal method has some assumption. And the assumption is between C and D, which is your existing ground, this is a straight line. Is that true? Does it have to be a straight line all the time? Or sometimes it is going to be like so. Watch this. So I'm going to take here a curve. I'll connect my point C to my point B with a curve. I'm asking you, does it have to be all the time straight line or it can be a curve? It depends. Sometimes the ground is sharp, like if you have a rock or something, and sometimes your ground is smooth if you have a sandy area. And that's why one of the mathematicians long time ago, and his name was Simpson. So Simpson, he was a mathematician and he looked at trapezoidal method and say, oh, the assumption here is line. Maybe it is not true. Why don't we figure a method or rule to find the side area based on the assumption that this is a second order polynomial? So this guy here is a second order polynomial or parabola. And so Simpson came up with a new formulation, a new method called Simpson method. Simpson method. Okay. So there's a typo here. This is supposed to read Simpson, huh? So I'm gonna hide it. So this one is supposed to read Simpson. I'm sorry, it's here. Some Simpson. Okay. So Simpson, he came again with another formulation. And you know what? I'll let you enjoy this formula here because I know that none of you, I guess, none of you, except if you are giga and math, you will read this equation. It's very hard to read. I will explain it to you later on, and you will see it's not difficult. It's easy. Okay. But this is what he proposed. So Simpson say, you know what? I'm going to assume a second order polynomial parabola, and here is the formula you should use to find the side area. Okay. However, before we do that, Simpson put some conditions. The condition is number one is the number of the cross section must be odd. And some of you will ask me, what does mean number of cross sections? It means the number of depths should be odd. What is odd? It means 3, 5, 7, 9, 11, 13, and so on. So the number of, or the count of the depth of cut must be odd. Okay. Number two, same as trapezoidal method. It says here your x must be constant. So which is the 25 meter. Okay. Now let's go to our problem and see if this is happening. Let's see. Number one, please check. Do we have a constant spacing between the sections? Yes, we do. 0, 25, 50, 75, 100, and so on. So looks like we have a constant interval, which is 25 meters. So that's number one. Number two, let's count our depth of cut. 1, 2, 3, 4, 5, 6, and 7. So 7 is an odd number. It means, yes, I can apply the Simpson rule on this method here. Remember, Simpson rule, which assumes a smooth curve for the existing ground, needs two conditions to happen before you use it. If those two conditions are not met, and both of them, they must be met, not only one, two of them. So which means the spacing or the interval should be constant. In addition to, if you count, the depth of cut must be an odd number. It means 3 or 5 or 7 or 9 or 11 and so on. Okay, so as soon as you verify those two conditions, we can use the Simpson method. And now I'm going to take you to look at this. So let me ask you, who likes this equation? Like x over 3 c1 plus cn plus 4 c2 plus c4 plus all the way to cn minus 1 and then 2 multiplied by c3 and c5 to all the way to cn minus 2. I know that probably maybe only one person in the class like it this way. If you are really good at math and you've dealt with high level math, but again, normally students, they don't like it. And I'm going to show you right now a better way to do that. I think somewhere here on my slide, I showed you the Simpson method in a plain English. So the plain English is here, okay? In plain English, watch this. So in plain English, this is how we do the Simpson. X over 3, no super signs. You're 25 meter over 3. Multiply it by a big bracket that includes 3 terms. That's unlike trapezoidal. Trapezoidal has 2 terms. The first one is the same as trapezoidal. The first plus last. The first plus last. Okay, the first depth of cut plus last depth of cut. And then plus 4 multiplied by the sum of all the even depth. Plus 2 multiplied by the sum of all the odd depth, excluding the first and the last. I know even this, with this plain English, even some of you struggles to understand how can we use Simpson. Then let's put it in action. Now watch this. So I'm going to go to the method. Here is the method, and I would like to apply Simpson to this method. As I said before you even touch or write any equation, what should I do? Before I even start writing my Simpson equation. Number one, please don't start right away. Number one, make sure that the two conditions are happening, which is the interval constant? Yes. Is the number of depth of cut constant? 1, 2, 3, 4, 5, 6, and 7. So we have odd because 7 is odd. Then both are happening. It means yes, I can right away apply my Simpson rule. Let me show you. The way I do it myself, I'll show you the best way. The best way is, don't worry, count. So right here, that's number 1. And this one here is number 2. And this one here is number 3. And this one here is depth number 4. And this one here is depth number 5. And this one here is depth number 6. And the last one is the depth number 7. This is the safest way, okay? Now, what you do next is, let's write the equation. So side area equals, we're dividing 25 divided by 3, trapezoidal divided by 2, Simpson divided by 3. And then watch this. I'm going to have a big term. And then inside my big term, I will have 3 terms. One term, and then plus another term, and then plus a third term. I do it this way personally. So I write here an empty bracket that will include later on one term, and then a second term here, and then a fourth term here. Okay. Now the fourth term here is, let's do that. So the first one is multiplied by 1. The first one is multiplied by 1, but we don't write 1, huh? The second one is multiplied by 2, so asterisk 2. And the last one is multiplied by 4. So 4. So I'm getting ready to write my Simpson. Okay, now the first term is so simple. This exactly like trapezoidal, which is the first plus last. I'm asking you, I need some help, please. Can you tell me the number? Should I write here? First plus last.
1.9.
Plus?
2.85.
Thank you so much. That's correct. So that's the first plus last. And then 2 multiplied by the sum of all the odd, not including the first and the last. And remember, when we say odd, I'm not referring to the value, not referring to the value of the depth of cut. I'm referring to the count, which means, look at this. We have here 1, 2, 3, 4, 5, 6, and 7. So which one are the odds, not including first and the last? Watch this. It's going to be number 3, and it's going to be number 5. It means I come here and say here 2.8, and then plus number 5 is 1.85, and then close this bracket. Then finally, plus 4 multiplied by the sum of all the even, huh? And remember, when I say even, one more time, I'm not referring to the value of depth of cut rather than the count, which means the second, the fourth, and the number 6, which means in this bracket here, I'm going to say 2.4, which is the second, plus number 4, which is 1.93, and then finally plus number 6, which is 2.35. Okay, so this is how I find my side area. Are you guys following so far? Are you able to use the Simpson method? Do you know what are the conditions for the Simpson before you start?
Yes.
Okay, so I have a tip for you, and this tip, again, please don't ignore it because this is based on years of experience. My students typically, when they solve this problem, right away, without any calculation, without any thinking, they jump right away and they say SA equals 25/3 and start writing. Please don't do that. What you have to do before you write a single number is to check the conditions. Number 1, do I have a constant interval? Yes, we have. Great. Good. Number 2, is the count the number of depth of cut even? No, I can't, so stop. Odd? Great, let's do it. Okay, so that's the way how we do it. Check the conditions. Once the conditions are met, then we can use the Simpson method. Now, there are a few questions around this discussion. Number 1, some of you will ask me, should I use Simpson or trapezoidal? I know some of you already by now asking the same question. Should I use Simpson or trapezoidal? Did you guys ask this question? Did any of you ask this question? Should I use Simpson or trapezoidal?
Yes.
Okay, so great. So here's the answer. So the answer is, in real life, it is not somebody will have to tell you use Simpson or trapezoidal. Remember, it's a mathematical method. It is up to you. The mathematical method will not really scream and say, don't use me. It will simply, you can use it. However, really the answer is, it needs an observation. You or the surveyor will have to tell you the ground is smooth or the ground has sharp broken line. If the ground is sharp broken line, which method you think is going to give you the best results?
Trapezoidal.
Trapezoidal, because simply the reality matches your assumption. How about if the ground is sandy and it's a very smoothly transition? Which method will give you a better results?
Simpson.
Simpson method. So correct. So this is in real life. In real life, it needs an observation from you. And by the way, you can mix and match. And what does it mean? For example, if the ground for the first kilometer is simply sandy, so it means you can use Simpson. And then if the ground changes to a different pattern with a broken line, then we can use trapezoidal. So you can mix and match. Nobody's going to stop you. Really, the bottom line is your method assumption must match the reality. How about an assignment or midterm exam or something like that? It is me. I have to tell you, please use Simpson or use trapezoidal, or maybe use both and compare the results. Remember the method. The method, as I said, you can use any method you like. It's a matter of does my method have assumption equal to the reality? Does it match the reality or no? If it matches, great, it will give you the best results. If it doesn't match, then no. Now, one more thing is, some of you probably by now will ask the question, okay, Tahir, what happens if one condition is not met? For example, you are using trapezoidal, you look at the numbers of the station, which goes 0, 25, 50, 75, and then all of a sudden, you don't see your 25 meter. For example, watch this. Let's say this number at the end, this number, it is 150, 155, okay? What do you think? And remember, this is something, it's going to happen because not every single pipe will have to be multiple of 25 meter. What do you think? Does it have to be?
No.
Which means normally probably the last offset will be something different than 25 meter. Okay, so now I guess some of you already are figuring out, can I use Simpson, or sorry, trapezoidal to estimate the total side area for this case? I guess no, because simply at 25 at the last section between 125 and 155, it is simply 30 meter, which simply not the same constant interval. And this is, we need to do something, okay? Now also let's go to the Simpson. Let's say Simpson, I have a Simpson and I'm asking you to use Simpson and you're trying to check the condition. Condition number one is okay. So it's 25 meter. However, when you try to check how many depth of cut, you figure out it's 8. And 8 is not odd. 8 is an even number. What can I do that time? Okay, we need to do something. And this thing you will learn in the next class. Okay, so the bottom line is, which I want you to take to the next class, is I cannot really use the method before I check the condition. And there is something we kind of never did finish it, which is I'm asking you here. Remember, based on this equation, I'm going to find side area. Do you think this side area, if I repeat the side area, does it have to be 100% like the side area using the trapezoidal method? So what you see here on my screen is the side area using Simpson method. My question to you is it going to be the same when I estimate using trapezoidal method?
No.
No. Why is that? It's very simple. The answer is logic, huh? Because we're using different method and every method has its own assumption and it is not necessarily they have the same number. So there will be a slight difference between SA from trapezoidal and Simpson. The lastly is, remember, we are not finished. Are we? When we find the side area, are we finished?
No, you need to multiply by the width of your trench.
Exactly. So the last step is we need to take the side area, multiply by the total width of the excavation, like what we learned here, and this is what will give us the total volume. Remember, I'm going here, and I know probably some of you are probably bored, but I can tell you I'm trying to make a good foundation for this part here, but things will speed up in the next class. For now, do you have any question? Okay, fantastic. You guys enjoy the rest of your day. We'll see you guys on Thursday. Thank you so much.
Thanks. Have a good day.
Thank you.
Thank you so much. Have a good day. Bye-bye.